Alright, if you're looking at this problem, 2a squared minus 50. Right now, that is not a difference of squares. But both of these terms are divisible by 2. So you can take out your common factor of 2, and then you'd get 2a squared divided by 2 is just a squared, and negative 50 divided by 2 is negative 25. So now inside the brackets, this is a difference of squares. I could write that as 2 times a squared minus 25, I can write as 5 squared. Perfect. Now you've got a difference of squares and you can factor it as 2 is still there, then you have an a minus 5 and an a plus 5. And you're done. Okay, part B. Now again, 3x squared and 12y squared, those aren't perfect squares, the 3 and 12. But you have a common factor of 3 here. So if you take out your common factor of 3, inside the brackets you end up with x squared, and then negative 12y squared divided by 3 is negative 4y squared. So I could write this as 3x squared. The 4 is really 2 squared. So 2 squared times y squared, I could write that as bracket 2y squared, and then the end bracket. So this is now a difference of squares. Your a term is x, your b term is 2y. So it factors out as 3 times x minus 2y times x plus 2y. And you're done. Part C. This is a tricky one because the 144 and the 4 are both perfect squares. So you could factor this as a difference of squares as it is. The problem with doing that, if you did that, you would have an incomplete factoring, because your first step whenever you're doing factoring is to see if there are any common factors to take out. And in this case there are, because the 144 and the 4 are both divisible by 4. So your common factor is 4. 144 divided by 4 is 36. So you have 36p squared q squared. And then 4 divided by 4 is 1. So this goes 36, I know, is 6 squared. So 6 squared times p squared times q squared, I could write as, in brackets, 6pq bracket squared minus 1. And the minus 1 I can write as minus 1 squared. Now we have a difference of squares format. And you write that as 4 times 6pq minus 1 times 6pq plus 1. Just to show you what would have happened if you hadn't found the 4 to take out. I know that 144 is 12 squared, so I could write this as 12pq squared minus 2 squared. So this I could write as 12pq minus 2 times 12pq plus 2. The problem is each of these brackets aren't completely factored yet because they still share a common factor that you could take out. So if you'd started like this, you would have to look inside the brackets here and say, oh, this isn't finished yet, and keep going. If you took out a 2 from this bracket, you'd have 2 times 6pq minus 1, and then you'd have to take out a 2 from the second bracket as well. So times 2 times 6pq plus 1. 2 times 2 is 4, so you would end up writing it as 4 times 6pq minus 1 times 6pq plus 1. So you'll eventually get the same answer. The problem is it's such a temptation to leave it at this and forget that there are common factors to take out. So always check your original question first to see if it does have common factors. Okay, on to part D. So here both of these terms are divisible by 3, and they're also both divisible by x, so your common factor is 3x. Then 3x cubed divided by 3x is just x squared, and negative 27x divided by 3x is negative 9. So I could write this as 3x times x squared minus, and instead of writing the 9, I can write that as 3 squared. So now I've got a difference of squares format, and it factors as 3x times x minus 3 times x plus 3. And there's your answer there.